So we now have John Mailhot from Imagine Communications. He's going to give a slightly different perspective on the aspects of working with audio as mono or multi-channel environments using IS-08. So take it away, John.
All right. Okay. How's our levels? You hear me okay? Yes? Okay. So I have to drive Jessie crazy by pacing on the stage and making her track. As Wes mentioned, I'm John Mailhot from Imagine. And so we're talking similarly to the talk you just heard about audio track patching. And really, in any production, right, audio is the hard part. Until you do HDR, then HDR is the hard part. But audio is the hard part of a lot of productions because different people in the air chain want to organize the audio differently. So AES-67 conveniently says you can put channels into streams together, but different users of the plant have different wants. So in playout and in master control and distribution, typically people keep mixes together, so 5.1s and stereos that are programmatically related. But on the production side, if the audio is organized in some pattern, it's usually physical. It's the microphones from stage left, the microphones from stage right. Those are the kinds of groupings you might see. Well, and both of those have exceptions. Sometimes it's a voiceover channel or something else that's just unusual. So while for the most part, you could do this, right? IP didn't create this headache. Audio has always been difficult to organize. But maybe audio can solve the problem instead of making it worse, or IP can solve the problem instead of making it worse. In IP, we organize these channels into streams, and ISO4 lists the streams. It's how you find what's in the network. ISO5 says how to tell the receiver what stream to take. But that's fine, but that's a stream. What if I want to do something about channels within a stream, or that's specified by channels within a stream? How do I do that? To the question of something like a shuffle, or an insert, or a substitution, or even a wild map, right? How do I do that when all I can address are streams? So ISO 4 and 5, obviously we treat the streams as monolithic essences. But operationally, you need to be able to say, I want to swap the left and right channel because I know they're wrong. You can't, there's no arguing it, you just have to do it. And there's a problem of maybe, some people ask, why don't I just make every audio channel its own unique multicast group? Just make them all separate. And you could do that, but there's a few, wow, I'm on like auto click, that's not good. You could make everything its own stream, but if you do that, you get this problem that it creates a huge number of streams in the network, which isn't itself a problem, but it makes everything harder. You'll find as you shop for receivers of audio that you have to keep asking, how many stream receivers do you have? And many audio devices don't have very many stream receivers. Maybe that'll change over time, but right now you have to ask that question when you buy an IP audio device, is how many stream receivers does it have, not how many fader banks, right? Well, similarly, in the way that these IP networks go, if you made every channel its own unique mono stream, when you switch signals, now there's a huge number of signals switching all at the same time at the stream level. So it makes the overall switching time longer and introduces, inter-channel switching differences that could be a mess. So, maybe that's not the greatest way. It's really not probably recommended. So what's this look like really? So imagine you're in a distribution environment, you have a playout system, you're switching it to your master control and your redundant master control. So usually the control system has some kind of bundle and you take a route like, playout system A to master control 1, and you just make one take, and the system under the hood makes 3 takes, one for this video stream, one for this audio stream, one for that audio stream. And these audio streams are maybe, 5-1 mix and stereo mix, something like that. So there you go. One simple route, another simple route, there you go. Well, the problem comes in here when you say, okay, I want to do substitutions. So I want to take, for here, I want to take this video, but I still want those audios. Well, ISO5 can do that, right? Because those are just streams. But now I have maybe another piece of the program that's coming in from a remote. I've got the video, okay, that's easy enough. And I've got two 8-channel audio streams. And these 8-channel audio streams, well, they aren't organized in my way. Like the channels that I need might be some weird arrangement across those. And it's just unique to this show. Every different show might have different things coming in that same receiver. So how do I manage this? How do I give my operations team a way to take the channels they want from here and get them mapped in? That's what ISO 8 gives us. So ISO 8 lets us have stream receivers that are managed with ISO 5 the normal way, and then affect this mapping of what happens to the channels from that stream and where do I put them after I get them. So in the normal case, I would say, that first route, take those things, map them up, and then these might be just some default mapping that's usually there. But then later, I go to take this, and I can do a wild map. I can say, take the video, don't forget video, it's important. And then for the audio, here's a bunch of specific channel routes. I want to take channel 2 of this and map it over to A1. I want to take channel 4 of it, take channel 4 of it and wrap it over to here. Take channel 5, and just pegboard it. And, from a user control standpoint, these routes can come from anything. They could come from an automation environment that's already pre-configured. They could come from a user control panel that's just got buttons for channels and you patch it just like the old days. It could be in a GUI with checkboxes. I mean, there's a million ways to generate this wild map in terms of user presentation. But under the hood, in terms of protocols and equipment, these routes are expressed as take the stream with ISO 5 and what to do with it, how to adjust this mapping in ISO 8. And so the two protocols together give us a way to control stuff. Now, why do we need ISO 8? Why didn't we just do this with, different protocol for every device? Because almost every audio receiver device has that map and has some way to control it. But then you get into the whole thing about drivers, right? So like we make control systems, other people make control systems, and as an industry, we spend way too much effort writing drivers for each other's equipment. And so what ISO 8 does is give us a standard API that when implemented, different devices have the same API, expose this map, so now I don't need to write a special driver for every device. So as you purchase equipment, ask the question in your RFP, say, do you support ISO 8? And if the vendor comes back and says, no, I don't, then you should mentally factor that you're going to have to spend money to get a driver written for that device because it didn't support ISO 8. Or maybe you would decide to preferentially buy a device that did support ISO 8. But that's really the key here, is to make sure that when you buy equipment, you make the right features in your purchasing list and say it's got to do this, it's got to do this, it's got to do this, it's got to do ISO 8. So, do we need it? Yes, we really need it because nobody likes writing these drivers, and ISO 8 gives us a common API that then we can use for every device that supports it. Now, is it done? That's always a question people ask. Is this done? Is this future? So it's been tested at workshops. It's been implemented by multiple vendors. We've done interoperability testing to make sure we all do it the same way. And it's a specification on the AMWA website. It's published. So it's free, even. Just like it should be.
Okay, very good. John, thank you very much.